Here is how we make alkyne. Start with alkene. If you still remember in chapter 7.2, we learned about an elimination reaction, E2 specifically. Start with an alkyl halide, add a strong base, mechanical and anti-mechanical, remember that? So do an E2 reaction, you're gonna get an alkene. Basically, an E2 is used to form a pi bond, right? So you get a pi bond, sigma bond here, because I got sigma bond and a pi bond. Well, alkyne just one more pi bond from an alkene. We do E2 twice, right? And to be able to do E2 twice, that's 2 pi bonds. That's a triple bond, basically. All right. But to be able to do an E2 twice, you're gonna need 2 leaving groups, 2 beta hydrogen. Right? So there's one E2 and then another E2. So do it twice, you get to alkyne. That's like the whole concept of it. Right? All right. Let's take a look into more detail. So we're gonna do 2 E2 reaction. The base for making alkyne is usually, you're going to see a very common one, sodium hydride, right? This is liquid ammonia, which is a solvent. I'm not sure you know, so ammonia is a gas at room temperature. This solvent right here is liquid. The temperature is really, really cold. The boiling point of ammonia is negative 33 degrees Celsius. That's about negative 20 something Fahrenheit. It's really, really cold. Right. So anyway, so this is in solution. So add geminal dihalide. Geminal like Gemini mean twins. So this bromine are bonded to the same carbon. They look alike basically. All right. So we call geminal dibromide. All right. Add sodium amide. Do an E2 twice. That's 1. And then E2 again. So beta hydrogen elimination. You will get internal alkyne. You can also do the same reaction, exactly the same reaction with bixenol dihalides. Right? So bixenol, so they are in this case halides are on carbon next to each other. We call bixenol, like vinyl. Probably familiar with that? So these are carbon next to each other. So require 2 equivalent of sodium amide. So the 2 of them, just like the top one. So you get to alkyne, the same thing. Okay. All right. So for the terminal alkynes, require 2 steps. All right, so it's different from, I go back here, so different from this is internal, you get internal alkyne. Add sodium amide, you get it right away, right? But terminal alkyne has more applications. We're gonna deal with a lot more with the terminal alkyne than internal alkyne. Okay, so to make a terminal alkyne, there are 2 steps required, and here's the reason why. If you look at the first step, so same thing. You have to do elimination twice, right? E2 twice. So first elimination, you get that, and then second elimination. Okay, so you get to a terminal alkyne. However, the reaction doesn't stop here. Another equivalent of sodium amide. So we add excess. So we have a lot of this guy floating around. All right. So this guy, another molecule will deprotonate an alkyne. If you still remember, so sodium amide is a strong base and strong enough to deprotonate an alkyne. So pKa 38 go to that direction. So the leftover sodium amide, which is a lot, will deprotonate this terminal alkyne and go all the way to alkynide ion. All right, and notice that this is ionic compound. So from now on, if you see any ionic compound, anything that from ionic bond is really stable, and that is the driving force that drive the whole reaction forward. All right. If you still remember the intermolecular interaction, the strongest one, ionic bond, with ion dipole, hydrogen bond, dipole, and the weakest one is London forces. All right. Anything that can from ionic bond form a strong bond, and that's the driving force drive everything forward up to that point. Okay, so all right, but now let's take a look. So the first step here, we don't stop at the terminal alkyne that we want, right? We stop at alkynide ion. So if you want to get to terminal alkyne, the desired product, you have to protonate this alkynide ion. All right, so we need to add an acid, and in this case, water will do just fine. All right, so protonation, and water pKa 15.7, pKa of terminal alkyne again 25. So equilibrium go forward, of course. All right, that's the reason why we add water. Okay, so and this step is called quenching. So quench, right? So quenching. There are two purposes of adding water, and this we call quenching step. So we just talked about this is number 2. So proton transfer to obtain the desired product, right? Because the first step we don't get to the desired product, so we have to add water to protonate that alkynyl ion to get to the desired product, basically. Okay. All right. And another reason we add water is water can react with the excess sodium amide, the leftover, and to convert it to a less basic compound, sodium hydroxide, much less basic than sodium amide. Okay. So we have to stop the reaction, basically. So we add water to stop everything there. All right. Okay. Let's practice together right here.